In example 12, we are told to solve 2 tan 2y tan y is equals to 3 for the range of y to be between 0 all the way to 2 pi. This question is already worked out, and I just want to explain what is on this page so that we all follow. And we have a point of reference. Having understood the double angle formulae, we have the tangent of 2y here, whereby we know 2y is equals to tan y plus tan y all over 1 minus tan squared of y. From a previous video, we understood this and we were able to evaluate it. This can be, when you put together the numerators, we have 2 tan y everything over 1 minus tan squared y and close the bracket. But there was a 2 in front of this term, so this 2 multiplies that term. So we have 2 tan y over 1 minus tan squared y, close bracket, and then we introduce this tan y here, which now is equals to 3. Now, since all of them are in terms of tan, we can simply open the bracket and have 2 times 2 is 4. Tan y times tan y is tan squared y. Of course, all over, the denominator does not change. 1 minus tan squared y is equals to 3 over 1. Now, if we cross multiply, because this is a fraction and this is a fraction, and when 2 fractions are equal, then we have all the permission to cross multiply. So we have 4 tan squared y is equals to 1 times 3, and minus tan squared y times 3 becomes minus 3 tan squared y. Collecting the like terms, when this one negative 3 tan squared y comes over to this other side, it is now added to 4 tan squared y because they are like terms. So 4 plus 3 gives us 7 tan squared y is equals to 3. And therefore, we just divide both sides by 7. We have tan squared y is equals to 3 over 7. And looking for the square root of both sides, we have tan y is plus or minus 3, the root 3 over 7. The reason why we are talking about plus or minus is because we know the square root of any positive number is always a plus or a minus. When we evaluate using our calculator now, and because the range is supposed to be in radian form, then our calculator should be in radian mode. After we establish now, there's a certain angle y whose tan is root 3 over 7. And the root 3 over 7, which is positive, then that angle is 0.58 radians. And because the tangent is supposed to be positive, the angle is supposed to be positive or minus, then the angle fits in all the 4 quadrants. Because in the first quadrant, tangent is positive, so it fits there. In the second quadrant, tangent is supposed to be negative, and due to the negativity, it fits there. In the third quadrant, it fits there. In the fourth quadrant, it also fits there. But there's a certain angle which is 0.58 radians. So the angle between the horizontal x-axis and the line of angle is 0.58. So in all of them, so y can be 0.58. When you come to the second quadrant, y can be 180 minus, which is 180 is now pi minus 0.58, which is 2.56 radians. In the third quadrant, y can be pi plus 0.58, which is here, pi plus 0.58, which is 3.72 radians. And in the fourth quadrant, y can be 2 pi minus, because we go back, 2 pi minus 0.58, and we get 5.70 radians. And at the end of the day, you realize that there are 4 possible values of y, which is 0.8, 2.56, 3.72, and 5.70. Remember, it was possible to solve this question because we know we understand the double angle formulae, and we know how to express tan 2y in terms of tan y plus tan y all over 1 minus tan squared y. If we didn't know this, then it would have been a bit difficult to solve this question, but yes, there we are, and we have actually achieved our values of y. All right?